Okay, folks, I'm going to go over these practice problems for Hardy-Weinberg. I'm going to do one of them in full, and then hopefully that'll set you up for success down the future here. You're going to want to have the AP Biology equations and formula sheet out in front of you, so dig that thing up. You're also going to want to have a calculator, because a lot of these problems require a calculator. I have taken question number 1 right here, and I have put it into a Jamboard so I can write on here. I'm going to move this over because that's going to bother me. There we go. And here we go. Okay, so sickle cell anemia is a condition caused by the inheritance of 2 recessive alleles, designated little a, little a. So we're going to pause here and think about this. To have sickle cell anemia, you have to be homozygous recessive, little a, little a. 2 million African Americans, or 1 out of every 12, have the sickle cell trait. Or in other words, 1 out of every 12 is little a, little a. 1 out of every 12 people is little a, little a. Calculate the following. So it says, calculate the frequency of little a genotype. So if we get out our formula sheet and scroll down here, remember that Hardy-Weinberg and our probability laws are up here. We're going to need those, and I've posted them right down here, okay? So the frequency of the little a genotype. Hopefully you recall from class, our discussion was about the fact that little a, in order to end up as an individual that is little a, you ended up with a recessive allele and another recessive allele from the gene pool. Well, what were the chances that that happened? Well, recall that the chance that you got a recessive allele is the frequency of the recessive allele in the population. That's Q. The chances of getting that, and we talked about, instead of allele 2 here, we talked about the fact that that should be the recessive allele. The frequency of the recessive allele is Q. What were the chances of getting that? Well, that was just Q. What were the chances of getting this? Well, that was just Q. What were the chances of getting this and this at the same time? Remember, laws of probability, if it's an and situation, not an or situation, but an and situation, the probability of the first event and the second event, you multiply the probabilities together. So you take this and you multiply them. So we're going to take Q times Q, which is Q squared. And that's why this here exists, because it represents what little a is in the population. So what we're saying with the first problem here is the frequency of the little a genotype. It already told us up here that it's 1 in every 12 is little a. So that's 1 out of 12. So doing the math here, I'm going to carry all of this out here. So Q squared equals, and then you grab your calculator and you go ahead and you do 1 divided by 12. And that's going to give you, I got to do it again here, sorry. 1 divided by 12 is going to give you 0.083. Well, that's Q squared. Now we can solve for Q. The key here on all Hardy-Weinberg problems is as soon as you can solve for P or Q, do it. So Q squared is this. So how do we get Q all by itself? We get the square root of both sides. So we're going to get Q then is equal to, and then that's where I'm going to get my square root of my answer, and that's going to be 0.288. I'm going to round that out to 0.29. So now I know that Q is 0.29. Well, as soon as I know Q, with this equation in mind, I should know P immediately. So P should be equal to, because P and Q have to add up to being 1. So 0.29, P has got to be 0.71. Okay. So now I've got my P and my Q, and I can solve anything with Hardy-Weinberg now. So it's always the first speed bump here of these problems is always to try to get to either Q or P, and then as soon as you have P and Q, you can get everything else. So let's look at letter B here. It says, what's the frequency of big A, little a? Well, if you recall from your Hardy-Weinberg equations again, big A, little a, heterozygotes, that's these folks, 2PQ. So big A, little a, that's just 2PQ, which is 2 times, well, P was 0.71, and Q was 0.29. So we're going to take 0.29 times 0.71 times 2. We're going to get 0.41 here, 0.41. What's the frequency of the big A? Well, big A is P squared. So we're just going to solve for P squared now.
I'm going to go to the next sheet here because it'll just be cleaner. So big A is p squared, which is 0. I'm going to go back here and show you that p was 0.71, right? So 0.71 squared. Well, what is that? 0.71 squared is 0.50. Okay. Then it asks down here, and sometimes on these worksheets, it'll just ask a question that seems really difficult, but it's actually pretty easy. The frequency of the dominant allele. And I put on here, look at your formula sheet. Remember that the formula, it tells you what P is here, frequency of allele number 1. And remember, I said that this is your dominant allele. And Q is the frequency of your recessive allele in a population. So basically what letter D here is asking is, what is the frequency of the dominant allele? Or in other words, what is this whole thing? That's the definition of P. So they're really wondering, what is P? Well, we already determined that. P was 0.71. And here they're saying, what is the frequency of the recessive allele? Well, that's just another way of saying Q. And we already determined that to be 0.29. So as you go through these problems, what you want to do is take the information that they give you, rearrange it so you know if it's Q squared or 2PQ or P squared, and then solve for P or Q. Then once you have P or Q, you get the other one because you can always get the other one from this formula. And then you plug back in and you go through it. So just to show you, just looking ahead here, you've sampled a population in which 24% of the population is hitchhiker's thumb, a recessive condition. Well, I can stop right there. I can know then that with 24% of the population, that's 0.24. It's a recessive condition. So I know that that's Q squared. Those folks are little a, or little h, or whatever it is. So now I just set that, and then I solve for Q, and I get my value for Q, whatever that is. And then as soon as I have Q, I can have P. And then once I have Q and P, then I can solve for probably the rest of these. These shouldn't be a problem. Okay. So that's ultimately how you work these problems. Hopefully that gives you a good start, and we'll work our way through as we need to. Take care and good luck.